Hi, Chris Kuzmal here. We're continuing our discussion of relational logic. We've already talked about truth assignments, and we've already talked about evaluation, which you do with truth assignments. And sort of the third ingredient in any logical sequence about logic is satisfaction. And for relational logic, the process is really not very much different than you have with propositional logic. You build a truth table, you evaluate for each possible truth assignment, you look for a true result, and if you do, then you have indeed discovered that you've satisfied the logical sentence. An example would be where you have a single unary relation. I'm sorry, we have two unary relations, P and Q, and two object constants, A and B. And for a few small example sentences, such as P of A or P of B, and the logical sentence for all X, P of X implies Q of X, and the logical sentence there exists an X such that Q of X, each one of them is indeed satisfiable. Each one of them can have a truth column created for it with respect to the set of truth assignments that can be provided for each of the members of the Erbron base. And this truth table thus corresponds to that. And that's pretty much all there is to satisfaction. It's not like there isn't a lot to satisfaction, but there's nothing new really for satisfaction relative to propositional logic. So now what I want to suggest is that I'm going to have a slight deviation because so far we've really talked about the content, which is a teacher talk for a curriculum, but we haven't talked very much at all about pedagogy. So how are you going to teach this? How are you going to learn this? And this is a situation where it's really good if you can form a group with other people and look in the book and present the examples that are in the book or present examples to one another. And what in my classroom, what we typically do is we make 4 examples where we have the modular arithmetic and the sorority world and the block world example. And then we also have students make up their own examples and then prepare them. I have this cute logical sentence down at the bottom of this slide that sort of expresses the algorithm for coming up with how you want to arrange your groups using relational logic, which is always kind of fun and recursive. And so what do I ask the groups to do? What I ask the groups to do is to be able to list the object constants, relational constants, and their arity for a world that they create. And so here, we've already done that for a world that I use as an example, where we had Dasha, leopard, ball 1, and ball 2, although I have a typo here still. And we have the relations blue, cute, and kicks, and the arity 1, 1, and 2. And then if we return to the slide for the presentation requirements, we see that you then want to explain at least 2 sentences from, well, if it's the book or if it's your own, then you explain 2 sentences that describe the world or which are at least propositional sentences about the world. And last time or the time before, we went through several example logical sentences. So we've done that as well. And we did actually provide both the English and the formal symbolic sentence, though. So for a couple of them, I went ahead and did that. For example, one we have for all X, blue of X implies cute of Dasha, which says that every object is blue. If every object is blue, then Dasha is cute. And note example 2, which just moved the parentheses around a little bit. And here we said that every blue object makes Dasha cute. The idea, the term makes is not precisely accurate with respect to logic, but it's close enough unless I want to go ahead and just restate the logical sentence. And that sort of thing, one part of the exercise here is to recognize that English has some ambiguity, but also English provides for meaning that is more intuitively understandable in exchange for an introduction of some of that ambiguity. And so that's what I would recommend people do at this point in the course, is that you should go and make your own world and create a presentation like we've talked about here. And then for extra credit, you can talk about pairs of sentences that, well, it doesn't have to be a pair of sentences, but some number of sentences that illustrate common quantifier, reversal, existential distribution, and negation distribution, which is actually coming up in chapter 8. And there's nothing wrong with looking ahead and seeing if you can understand the material